Hey there, friends. My name is Jeff Fritz, and I'm here to talk to you today about .NET Aspire. This is a series of videos that are going to teach you all about .NET Aspire, including not just what it is, but how to get it installed and running on your workstation, and how you can use it to adapt and make an application system work with .NET Aspire, and finally, how to deploy an application that's been built and managed with .NET Aspire. There's lots of great content in this video series for you. I want to make sure you check out all the learning resources that are available at aka.ms/letslearn/.net/aspire. All of the slides, the markdown, the content, the samples for this video and the series that goes with it are all available on our GitHub. Check it out at github.com/.net-presentations/letslearn-.net-aspire. So if you've been working with .NET for some time, you know that .NET is your application system that you can use to build anything. It's a united platform that gives you all kinds of capabilities to build for the cloud, for the web, for desktop, mobile, gaming, IoT devices, and even AI capabilities. We've got editors available for you like Visual Studio and Visual Studio Code, as well as CLI tools that allow you to work with any text editor that you'd like to write and build code that works with .NET. It'll run on Windows, Mac, and Linux, and there's a fantastic series of features available in an ecosystem, including packages running on NuGet, GitHub capabilities, as well as integrations, tools, and all kinds of libraries available from various vendors. There's a whole ecosystem that you can use to build whatever application that you dream of. But when you're building an application system, we know that every app needs things like observability, resiliency, scalability, and manageability so that you can work with and grow your application. Your application needs to be observable. You want to know those logs and metrics that are happening inside of your application so that if there is an error, if a customer has a problem, you can go through, diagnose, and fix it. You want resiliency so that if there's an issue with your application connecting to the various other dependent services that it has, whether it's a database or APIs, you want to be able to reconnect, retry, and make sure that if it doesn't work, it handles that appropriately and is able to respond correctly to your customers. You want scalability so that when your application does get that rush of customers, the visitors to your application that are using that application and they want a great experience with it, you want your application to be able to scale from one server to many servers as quickly as it needs to handle all of your customers. And finally, we want manageability so that our application can be managed easily when it comes time to grow from a small application to a larger application. We know with .NET 8, there are all kinds of features that have been built and included in the base framework to help with some of these four tenets that we want to address. For observability, we have built-in metric capabilities with dimensions so that you can see the performance numbers, how long various things took when you interact with them inside your application system. Dependency injection integration with metrics. You don't even need to configure these things because dependency injection will set up those metric management for you. You're going to get better logging support using tools like OpenTelemetry. You can enrich the interactions that you have with other services very easily with the tools in .NET 8. You can even redact your logs so that private and personal information doesn't end up leaking into your logs and potentially being exposed. There's testing with fakes for logging and metrics. We've also got resiliency features that are available, including poly-based resiliency packages and SignalR-based stateful reconnects of your application. And your application can scale much, much better than it has in the past because we have things enabled like ahead of time compilation. So you can compile and make your application run in a smaller memory space, in a smaller space on disk, so that you can run more instances of your application on the same server side. We've improved performance so that you don't need as much processor or memory to run the same application. We'll even run on chiseled Ubuntu container images so that you end up with a very small image that doesn't have all those extra things running around in the operating system that you don't need. And finally, for manageability, we added things like configuring auto rotation of your web server certificates, all built into Kestrel for you. But even with this set up, it's still not easy. Setting up and managing and connecting all those pieces is complex. If you haven't done this before, it can take a little bit of time to make sure that you have everything working together. That means that when the next developer joins the project team, they've got a difficult getting started experience. We want to make sure that developer that joins the team can get started and be productive as quickly as possible. That helps the whole team have a higher velocity and have a better return and delivery on the product that they're working towards. The choices that are available are kind of crazy. There's a lot of different pieces that you can stitch together here to build your application system, and how do we know that they're all going to work together properly? Which means that we want to also make sure we have a good paved path. What's a path that folks have gone through in the past that has proven to be a reliable and assured system practice that we can use in the future to build our application systems? While answering all of those questions and fulfilling those 4 tenets are what .NET Aspire is designed to do. It's a cloud-ready stack for building observable, production-ready, distributed applications. What's that mean? Listen, that means that we're going to help you whether your application is as small as a little website connecting to a database, or it's as big as a series of websites and APIs that connect through a service bus to a series of databases and data stores that have offline capabilities that are interacted with, and open AI interactions that are going to load and analyze and report things back to your customers. We've got all of those capabilities available for you to scale and grow into as you build your application. Who is it for? For any developer that is looking to build an application system. Not just .NET developers, any developer that's looking to build an application system. So should you use it? I hope by the end of this video series, your answer to that question is an emphatic yes, because we think that putting these pieces together to build your application system is going to make your development process easier, more friendly, and more productive for you to interact with your other team members to grow and build your application system. Now, when we think about a storefront application, something like this that you might have built in the past, it can go from being as simple as that website, maybe it's a Blazor application, connecting into a simple data source. And it could be as easy as a SQLite database on disk that just has a list of the various products that are available inside your store. As that grows and you swap out that SQLite database on disk, you may be swapping in a back-end API that interacts with identity, catalog, the orders that you're processing, the payment processing, and then finally saves data into Postgres. You can do all of that with .NET Aspire as it grows and helps you manage your application system. And finally, when your application gets to be as complex and as enterprise grade as something like this, where we've got mobile applications, web applications that are out there that connect to a back end for front end for the mobile, and the web app that's running with Blazor on a server in the cloud, and you have all these APIs that they connect into and interact with using Postgres databases and maybe a Redis cache, a third-party service like a payment processor, and you want to communicate back and forth with them using something like RabbitMQ. We can do all of those things and even work with admin services here that have webhooks and other web services, and at the same time have all the observability capabilities so we get logging and metrics being reported back from our system. So we can even dial in OpenAI at the end there to help introduce some cool new features for your customers so that they can get more out of your application. .NET Aspire is a complete series of tools that you can use to build your application system right now. It doesn't matter if it's as complex as this or it's as simple as that little website with an on-disk data store. .NET Aspire is going to help you out. I hope you stick around for the rest of the videos in this series. I've got a handful of them that are going to show you, coming up next, how to set up your developer workstation so you can work with .NET Aspire. We're going to look at how to take an existing application that was built with .NET and Aspirify it and allow it to work with .NET Aspire. And then finally, we're going to take a look at how we can take that application and deploy it and get it running out on a cloud service. Hey there friends, Jeff Fritz here, and in this video I want to show you how you can get your machine set up so that you can work with .NET Aspire to build your next application system. So what do we need to do to get configured so that we can get started with .NET Aspire? Well, we have a series of instructions that are available for you in the GitHub repository that accompanies this video series. There's going to be a link in the description just below so that you can get to that GitHub repository. This is documentation 1 -setup, and it will tell you how to get started right here. Now, if you're a .NET developer, you've probably got a bunch of this already installed and ready to go. Okay, that .NET 8 SDK, maybe it's the .NET 9 SDK. The latest version of the .NET SDK. It has to be 8 or more recent. You need to have that installed so that it has all of the .NET Aspire capabilities available to you. If you're working with .NET 8, you're going to need the .NET Aspire workload installed. Starting with .NET 9, there is no workload for you to have installed. We recommend you have Docker Desktop installed to help allow you to integrate with other services that .NET Aspire makes available to you as containers. And if you don't like Docker Desktop, you want to use something else, you can also use Podman to install and work with containers on your developer workstation. Finally, we recommend that you have Visual Studio 2022 or Visual Studio Code along with the C# Dev Kit. That'll help you get all of the tools and IntelliSense features that'll help you to write your C# code to configure .NET Aspire. It'll allow you to write that a heck of a lot easier. Now, if you're on Windows and you have Visual Studio, we recommend that you install Visual Studio 2022 version 17.11 or newer. Any edition will work, including the free-to-use Visual Studio Community Edition. Now, you're going to need to make sure you include these two workloads in the Visual Studio configuration: the ASP.NET and Web Development workload, as well as the .NET Aspire SDK component in the individual components. Let me show you the Visual Studio installer real quick and exactly where to find those. Here I am in the installer. There's my Visual Studio Community Edition. I'm going to click into Modify so we can take a look in a little bit further. And there's the ASP.NET Web Development workload right here in the top left. Click that one. Make sure you have a check on that to indicate that you do want that included. We also need to make sure we have the Aspire components selected. Those are under individual components over here. And if we just tell it to search for Aspire, there it says it's going to install the .NET Aspire SDK. Make sure these two items are checked and go ahead and click that install button right there, and it'll get your Visual Studio installation up to date with everything you need for .NET Aspire development. Now, if you're on a Mac, you're running Linux, or you're on Windows without Visual Studio, you can still work with .NET Aspire. You can install the latest .NET SDK, that's .NET 8 or later. On .NET 8, you have to install the .NET Aspire workload, which means you need to execute these two commands: .NET workload update and .NET Workload install Aspire. Now, if you're working on Mac or Linux, you may need to run sudo so that you're in a super user configuration to install the additional features that you need for .NET Aspire development. We also recommend that you check out and use Visual Studio Code along with the C# Dev Kit on those other systems for the same reasons I mentioned earlier. It's going to make your C# development a heck of a lot easier because you'll have IntelliSense and other features like debugging that'll help you build and develop your code in Visual Studio Code. All right, so we've got everything set up, and we can now go and test out our configuration by building our first .NET Aspire app using all the details right here at this link. Now, I've got you covered. We're going to take a look and build our first .NET Aspire project. And it's kind of a misnomer because the template that comes with .NET and you'll find in Visual Studio Code and Visual Studio 2022 is actually a solution that contains a couple of projects inside of it. But let's take a look and walk through that process right here in Visual Studio Code and see what it looks like and verify that our installation is running properly. So here inside of a new window, let me just bring up the command palette and I'll choose .NET New Project. And from my list of templates here, let me grab this one right here, the .NET Aspire Starter app, right there. And it's going to give me some choices as to where to write this on disk. I'll jump over here to my dev drive. I'll create a folder here called My First Aspire App. Copy that name, select it, paste it there. Project will be created in that location. Looks good. Go create the project. There's an API service, a little app host project there, something called service defaults, and then I know what this one is down here. It's a website. All right, so let's now go and use the debug tools that we have available to us in Visual Studio Code to launch and take a look and make sure that our application is running. We don't want to do anything too much more than that right now because we want to save that for a little bit of the demo that we're going to get into in just a few minutes. So I'm going to reach into my app host project here and open the program file. I'll reach into the debug panel over here and tell it to go ahead and launch and debug and attach to this project. It's going to open that in Microsoft Edge, and we're going to see a dashboard here that has a little bit of information about the API service and the website that are running as part of this solution. I can click this link right here, and it should open and show me that basic default Blazor website. Great. I can click through and see a counter here and a faux weather report that's being generated and served actually from the API service that was delivered as part of that initial template. Seeing that these 3 pages work, I've got confirmation that my workstation here is configured properly so that I can start building and working with .NET Aspire tools inside of my applications and system. Thanks so much for watching. Make sure you tune in to the rest of the videos in this series because we're going to get started in our next video building and working with an existing application and adding .NET Aspire features to that application so that it can grow and get all the features and tenets that I've told you about in .NET Aspire. Hey there, friends. Jeff Fritz here, and I'm going to start talking you through the beginnings of working with an existing .NET application and getting it running with some of the features that .NET Aspire provides for us. And in this episode of the series, we're going to specifically add service defaults into our existing project. Well, what is our existing project? There's a link down below in the description to the GitHub repository that has all the samples, the slides, and the documentation for this series. I recommend you check out that link and jump in and get started with us inside a folder that's labeled Start with API. Go ahead into that GitHub repository and grab that series of code that's in that Start with API folder, load it up in Visual Studio or Visual Studio Code like I've got here, and we can get started building and talking about our application. All right, so this is called My Weather Hub, and it has an API project here as well as a website down here on the bottom. And if we take a look at this, just to get an idea as to what it does, I'll go out to the command line and I'll start each of these two projects separately so that we can have them connect to each other and start talking and have the website query the API to go get some weather data for us. I'll open my command shell here and I'll start off with running that API project. So I'll go into API and I'll just .NET run this one. Now, as that's getting started, because I also want the website to go with the API, let me go open another tab, or I'll even split this window. I'll split it horizontally. And down here, I'll go to the website and start the website. So there's the Weather Hub, and we'll .NET run this one. So I have both my API running up top here inside my Windows PowerShell terminal here, and down here I have the website running. If I go to the API here, I'll just copy that address and we'll open up Edge and browse to that. If I go to the Swagger address, there's all the content for my API. It's out there, it's running. It provides the ability for me to search across a series of locations that the National Weather Service here in the States calls zones, and I can choose and request a forecast, a live forecast for a specific zone by going to this address. And we can see in our code exactly how that's configured to go and connect to the National Weather Service with this capability right here. I have a National Weather Service manager that knows how to connect to apiweather.gov and request some data with some endpoints. There you go. There's my zones that knows how to connect and get that data, as well as over here, the ability to get forecast for a specific zone that's passed in. Okay, that looks pretty clear what it's doing there. That's a garden variety web API. If I go back to my terminal, I should be able to click through to this location. I'll just copy that address, open another tab, and I can get to my website that's using that API to show me here now real weather forecasts. Now, this is being recorded in 2024 in the fall. The locations and the forecasts that I'm showing on screen as part of this video might not be the same that you see as you navigate around here. It's going to change. There may be different weather at different times because this is a live service, okay? So you can learn more about the U.S. National Weather Service with a link that we've provided over here. But over there, I'm using a quick grid to present a list of all the different locations, the zones that are available. So if we go in here, I can quickly search for Philadelphia using that filter hamburger button there. And if I click on Philadelphia, I can scroll down and it makes a second request to that API to show you, here's the upcoming forecast for Philadelphia in October 2024. And these look like forecasts that you might expect for the Philadelphia region. Highs around 80 this afternoon. Tonight, mostly clear in the evening. Lows in the mid-50s. Southwest winds 5 to 10 miles an hour. And so on and so forth. And you can see we put up 8 forecasts on the screen. Not bad. It's an easy service for us to interact with and get some data out of so we can learn more about what's going on with our weather forecasts. And because it's all being managed and run locally, I can cache some of this information and present it and share it with some of my colleagues and some of the folks that I work with to be able to take a look at the weather and hide all of that nonsense that we don't need from the National Weather Service APIs. So it's an interesting little service that we've got built here. But we want to start adding some capabilities for resiliency and reliability and be able to get some metrics coming out of this, some logging. Because right now, the only way that I get some logging is by looking at the console here, and that's hard to discern what exactly happened and requesting and back and forth. It's confusing how these are related to each other when I was just interacting with the website. And this is where the service defaults capabilities come in that we're going to introduce that .NET Aspire provides for your application system. Clearly here I have a little microservice that's my API, and I've got my website, and I want to allow both of those projects to have some reasonable logging and metrics and reliability built into them in case there's any kind of an issue interacting with my services. Because as I'm clicking around here, I could run into an issue navigating around and interacting with some of these, right? If I just take a look at some of my capabilities here, there's Franklin. Well, can't locate weather for Lawrence in Alabama. If I go to Madison, well, that works. Let me try Lawrence again. Yeah, Lawrence works now. So how do I manage and work with that as I'm building a system, and I want that reliability where sometimes these things, it's not always reliable to load and present that information. We do that with our service defaults. Let's head over to the documentation and we'll get started with that. The first thing we want to do to add service defaults into our application system is to create a service defaults project. Now, if you're in Visual Studio, you're going to right-click on the solution and add a new project. And we're going to create a .NET Aspire Service Defaults project template. And I've got some screenshots here for folks that are in Visual Studio, how to get started and work with those. But if you're in Visual Studio Code, we can create a new .NET project using the command palette inside of there. I'm actually going to do this at the command line by executing this command, .NET new Aspire Service Defaults, and we're going to name it Service Defaults. So I will cancel both these, and look, there's my error that I was getting inside my application. How would I have known? Let's clear that out. I'm going to jump up a folder and I'll execute that .NET new Aspire Service Defaults template, and we'll name it Service Defaults. We'll create that. There it is. Let's add that into the solution. So I'll execute .NET SLN add service defaults. There it is, and now it's part of the solution. I'll go back over to Visual Studio Code, and if we take a look at our Solution Explorer, there's my API, there's my Weather Hub, and there's service defaults. Take a look at what's inside there. What are these service defaults? Well, it's a series of extensions that it will configure for your applications automatically. It'll do things like configure OpenTelemetry, add health check endpoints, service discovery capabilities so that it can discover other projects, other applications in the system and connect to them. We won't have to create a little DNS server that replicates and knows where the applications are running. It'll also set up HTTP client defaults so that it'll have some standard resilience built into it, so it'll retry connections when they aren't able to connect properly. And we'll also get some service discovery in there so that we can locate the other components of our application system by name instead of having to specify some sort of localhost port combination. So we'll have all of those capabilities built in. And further down here, you can scroll down and see exactly how those various features are configured. I'll leave that to you to explore on your own time. We're going to configure the service defaults in both the API and the Weather Hub projects by adding references to the service defaults project, and then we're going to add a single line into both projects, builder add service defaults, and actually we're going to add a second line. Maps default endpoints will add right at the end so that it will add health checks into the application system. Let's head over to the command line and make these couple of changes. Now, if we were in Visual Studio, we could just add a reference, but I want to do this at the command line because everybody can do this work at the command line and make their projects better. So I'm up here in the top. I'm going to work with the API project. I will .NET add reference, and I'll just go up one to service default. And there it is. It added that reference. Down here, I'll go into the My Weather Hub project, and I'll execute the exact same command. .NET add reference up a folder, service default. And there it is. It has that reference now in the project. Let's go add those capabilities for adding the service defaults into both projects. So I'll start with the API, and we'll go into the program here, and we're going to add services to the container in the top half. Well, right here after we add the Swagger generation capabilities, let's add service default. We'll go down to the bottom here, and after map API endpoints, we'll do app map default endpoints. Okay? We'll do that once again for the web project. And I'll go find program over here. And right here, after it adds the Blazor services, we will once again add service defaults. I'll scroll down here. And after it maps the Razor components, app map default endpoints. There it goes. Okay, that's all we needed. We can now run the application. Now, if we were in Visual Studio, we can have it run two applications, two projects at the same time by setting up multiple startup projects. But I'm not. So I'm actually going to run these as two projects, just like we had here previously. I'm in the API folder up here. So I'll .NET run that project. And down here in the website, I'll .NET run that one. There they are. They're both running. Let me go back to the website, and I'll reload the application. There it is. And if we look back over here, we can see there's connection attempts that are being made from the website. Look at this, with standard retry policies. Ooh, I like seeing that already. Okay. Let's try clicking through here a little bit. So I'm just going to click into a couple of these to see if we get that error, right? Look, there was a little spinner there that ran for a little bit. Okay. If I come back over here to my terminal, if we look up here, look at this. Right over here. Poly is reporting that it had a problem. Look, there was a 500 error coming back, and Poly comes through and says, hey, we're going to retry this. Here's another execution attempt with that standard retry policy. It was a resilience event occurred on retry, and it came back properly with a 200 result code, and everything ran properly. So we added that resiliency into our application. We've also got health checks in here now. So if I take this address and we just type /health on the end, you'll see that my website reports it's healthy. And that may be important to you when you deploy your application and it's running in some sort of a large orchestrated system, and you need to know when web servers are healthy or not, right? If I go over to my Swagger UI, it's still sitting there for my API, and I can go to that same health endpoint, and I can see that it reports that it's healthy. I didn't add these features. I didn't have to go and change any of my code. All we did was add service defaults, and it enabled our HTTP client to behave better with retry capabilities to add that resilience. And it gave us health checks that did some default health monitoring inside of my web applications to make sure that they're operating properly and return a healthy status when there's a probe that comes through from some sort of orchestration monitoring tool to see if our web servers are behaving properly. That's all for this episode in the series. we've learned how to add service defaults into our project to allow our websites, to allow our applications to run with a little bit more resiliency and to start reporting their health status. We're going to get into more configuration with .NET Aspire in the next video in this series. I hope you come back and check it out. I've got lots more to show you, including our new .NET Aspire dashboard and how to configure and deploy your application that's been built with .NET Aspire. Hey there, friends. My name is Jeff Fritz, and welcome back to this episode in our Get Started with .NET Aspire series. Now, today we're going to take a look at how we can start to add the capabilities to orchestrate and take a look at a dashboard that presents information about our application system or our distributed application that is being managed by .NET Aspire. Check out the previous videos in this series if you have questions about how to get started with .NET Aspire, what you need to install to get started. What is .NET Aspire? They're all available for you in this video series. All right. Now, today, we've got an application that's been built to query the National Weather Service here in the States that we're going to use that already has some service defaults configured from our last episode that we're going to set up to do a little bit of orchestration to manage an API and a web application that communicate with each other. And we're also going to put together a cool little dashboard that allows us to see these web applications communicating with each other, along with some other interesting tidbits that come along the way here. All right. But first, before we get started, check out the GitHub repository. It's linked down below in the description. And we're taking a look at the documentation for episode 3 here, the dashboard-app host MD. Now, we want to make sure we cover some common terminology that's used inside of .NET Aspire systems. We're going to talk about an app model. That's a collection of resources that make up your distributed application or your application system. All right. For a more formal definition, we've got a link for you right here. We also have an app host or an orchestrator project. This is a .NET project that defines and orchestrates the app model, and it's typically named something.apphost by convention, of course. Now, we also have resources inside of our application system. A resource represents part of the application, whether it's a .NET project, maybe it's a container, an executable, maybe it's some other resource like a database cache or a cloud service that's somewhere out there that you're not managing. Those resources can all be identified and collected and organized together inside of our orchestrator project. Finally, we've got references, and a reference defines a connection between those different resources, and we're going to express that reference as a dependency using with reference API keywords. Okay? Now, for more information, we've got a link for you to learn more about reference resources. All right? Now, let's get started by creating an app host project. Now, I'm using Visual Studio Code here. If you're using Visual Studio, there's a great little user interface for adding projects to your solution. You can go ahead and do that by saying Add New Project. This interface appears, and you want to choose the .NET Aspire app host. In Visual Studio Code, you can also create a new .NET project. Use that at the command palette, and you can choose a .NET Aspire app host for .NET Aspire. Now that's okay. That's a good start. But I'm going to do this at the command line because I want to make sure that everybody has a similar experience. I'm going to grab this command right here, .NET New Aspire App Host, and we're going to name it App Host. I'm going to copy that, go over to my terminal, and in my top panel here, I'll just go up a folder and we'll paste that in so it's sitting right next to my other projects. And it's going to create that little app host project for me. If we take a look at the folders, you'll see there's my API, there's app host, My Weather Hub, that's the website, and of course Service Defaults, that's the project that we added last time. All right, let me head back over. Before I head over, let's add our app host into our solution, of course. So we'll do .NET SLN add app host. There we go. And now that project is part of the larger .NET solution. And that helps to keep things organized when I'm in Visual Studio or Visual Studio Code, and I want to see all of my related projects next to each other. So my API, my app host, my Weather Hub, and Service Defaults. If I go into app host now, you'll see I've got dependencies, properties, an app settings JSON, and then a program CS file here. And it has just 2 lines in it. Not too exciting just yet. But we're going to add some project references to our app host so that it knows those resources that it can interact with that are also in the solution. We want to add references to the API and the Weather Hub projects so it knows what those are and how to orchestrate those. Now, if you're in Visual Studio 2022, you can right-click and add references, or you can even drag and drop one project onto the other so that you add a reference from the API project and from the Weather Hub project into the app host. I'm going to do this at the command line though, because I like to type a little bit. I'm in the root project here, the root folder here. I'm going to go down into app host and we will .NET add reference. And we're going to tell it to add a reference to the API project right there. Let's do that. And now the app host knows about the API. Let's do that one more time, but instead of the API, we're going to add a reference to My Weather Hub. And now app host knows about both of these projects. We can confirm that by taking a look in app host CS proj. And if we let it go down to the bottom there, you see the 2 project reference elements here for API and My Weather Hub. It knows about those other projects now. If we look back at our documentation, the next step we want to do is start to orchestrate the application. Let's let the app host start each of those 2 pieces, those 2 projects in our application system and manage those. So we'll specify var API equals, and we'll connect to the API with this command, and we'll reference the Weather Hub with that command. I'll just copy those 2 lines of code and paste them in right here. So what's this doing? Well, our builder is creating a distributed application builder here and stashing it in a builder variable. Okay. And our distributed application builder is getting a reference to a .NET project. .NET has a special syntax that we can use here. And we're going to specify that it's one of our projects in this solution, projects, and it's the project named API. And we can see that in our Solution Explorer right there. We're going to do the same thing just below with My Weather Hub, projects.myweatherhub. The name API here in quotes and My Weather Hub here in quotes, that's a string that we're going to be able to use to reference this almost like a host name elsewhere in our application system, right? We can give it any name we want so we can reference and connect to that part of the application. Let's start the application the way it is right now and interact with those. But here's the thing. I don't need these 2 panels in my terminal. Now that my app host knows about the 2 different projects in the solution, I don't need this one. Inside my app host folder here, I can just .NET run, and it will actually start both projects. Check this out. I get a link to my dashboard right here that I can open, and I'm in the .NET Aspire dashboard. Look at this thing. It's beautiful. Okay. It's pretty simple at this point, but it knows about my two projects right there. There's my API, right? That API there is the name that I gave it in quotes, and my weather hub, and it's hiding right there. There you go, is right there. And I have the endpoints for them declared right here that we can connect into and take a look at. Look at that. Localhost 7032 Swagger, localhost 7274. And if I click into it, there's my Swagger API. And if I click into the other one, there's my weather reports. And it's still bringing back and showing me the weather that I had before here. Check this out. I'm clicking into these, and I can see the weather loading, and oh, that one's taking a little bit longer, but eventually it loads. The dashboard allows me to see and interact with the logs for these services. It's not sitting here at the terminal, but it's sitting on the dashboard for me to be able to explore and take a look at. Check this out. I have a logs button over here for each of the two services. So I'll click into that, and I can see that exact same console being reported in this web interface that I can dive around and I could see there was an error right there. But that's a pain in the neck to have to search through and find. And this is where OpenTelemetry comes in. When we started building the application a little bit ago, and we added the service defaults in our previous episode, it also takes these and exports these logs with OpenTelemetry to somewhere that might be listening for it. And when we set up the app host project will receive that telemetry and keep a rolling buffer of that content inside the dashboard. So I can come over here to my structured logs, and I can take a look and find warnings and errors and drill immediately into those interactions, and I can even view the details down here at the bottom and see exactly what the errors are and take a look further at what happened in there. There's my exception that was thrown that we can learn a little bit more about. This is just the beginning of what we can do with this. Because now that we have the two projects identified and the app host is managing it, now we can also get them connected to each other and do a little bit of service discovery. We can also see how these two applications communicated with each other in some distributed logs if we take a look at the traces over here on the left. Now, take a look at all of these. We've got log information coming in from My Weather Hub and from the API that we can drill into and see what's going on. Look at that. We see that there was a request to My Weather Hub, and it made a request to the API, and then it further made a request out to API Weather Gov. And we can see exactly how long those steps took. If we back up here, we can even drill into that error, and we can see exactly where the request was, and there's the error scenario down at the bottom. So we've got a tremendous amount of insight that we have into how our application is working using these distributed logs. I even get OpenTelemetry metrics being logged for me. So if we take a look at the API over here, I can even see a graph that shows the number of exceptions that were thrown by the application. And I can bounce over to the weather application, and I can see how many active requests are coming through to the application. I can see how long those requests took to process. There's nothing that's taking a long time to process right now. But if I go up here and request something else, I'll be able to see another request come online here in just a second that shows that it was processing and working with that data and showing information on the website. And you can see it slowly starting to crawl in here and present information about how the website is working. Really great stuff. And at this point, we have our dashboard working, and it's showing some really cool stuff about how these two web applications communicate with each other and interact to present the total solution for my Weather Hub, my little weather service. Now, there's still more that we can do with this as we're going to introduce things like service discovery and we get ready to deploy this application in the future. I hope you tune in for the rest of the episodes in this series where we take a look at more that we can do with .NET Aspire and how we orchestrate our application. Hey there friends, Jeff Fritz here, and I'm here to talk to you a little bit about getting started with .NET Aspire. We've seen a handful of videos in this series already that introduce what .NET Aspire is, help you get started setting up your workstation so you can build with .NET Aspire, and even start to configure your application system to work with .NET Aspire. And today, we're going to talk about service discovery and how you can set up the various components of your application so they can discover each other using a friendly name instead of having to set up some sort of DNS or caching and passing around names of local host and port numbers. Ugh. We're going to make this a heck of a lot easier for you to build and connect those components of your application system. Now, there's a link just below in the description that'll get you into our GitHub repository that has the slides, the text, the instructions, as well as all of the sample code that you need to participate in this part of the video series. All right, so let's take a look. I'm using Visual Studio Code here, and I'm going to be working at the command line. But if you're working on Windows with Visual Studio, or maybe you're working in Visual Studio Code and you want to use some of the tools in the command palette there, you can do that. I'm going to work at the command line because I want to make sure that everybody sees that these tools work no matter where it is that you are in the .NET ecosystem. All right, so service discovery, this is that ability to connect services together and reference each other. Now, our Weather Hub project, when we left it, had two websites. It had an API called API and a website called My Weather Hub. And the API would connect out to the National Weather Service here in the United States and get information about weather forecasts and weather station information to present. And the My Weather Hub would format that nicely and allow us to search and interact with that data. Well, if we look at the project, we'll see that there's actually information inside the My Weather Hub project that specifies, here's the endpoint to get to that API. You're going to go to localhost 5271 to query and interact with that data. And I don't like having to hard code that, because that means when I get into a production space, whether it's on servers that are running in my data center or it's running on a cloud service or some other hosted service, I've got to remember to maintain this thing. That can be dubious, particularly if for some reason my API falls down and I need to reroute and connect to another API service that runs somewhere else. I want to be able to just generically reference, right, abstractly reference my API and be able to get to that location. And that's where service discovery is going to help us. So we're going to dive in and we're going to create a reference from our My Weather Hub project over to the API. And we're going to do it in the App Host project by adding this line right here. Check that out. With reference API. Let me show you. So here I am inside the program CS file of my App Host project. And where I added the project for My Weather Hub here, I'm going to add a reference using the with reference command here to our API project. And notice I use the API variable name there. Now, right, I could rename this to to my API, and it's the same variable that I'm referencing there. And that makes this connection from the weather web application to the API. Additionally here, I want to take that web project and I want to expose that to the outside world. I want to make sure that when folks navigate to my distributed application, they get to the Weather Hub, not the API. And I want to hide that API behind the firewall. So I can expose the Weather Hub website by saying with external HTTP endpoints. And that configures the Weather Hub project to be available as an external facing web address. So now that they reference and know about each other, let's actually take the information about the API and put that into the website. Now, the website starts up and configures a base address to connect out to the API using a URL it gets from this weather endpoint entry inside app settings. And that's what we saw earlier over here in app settings JSON, weather endpoint. And instead of pointing to localhost, we can change that and make it a little bit easier to work with by saying instead of localhost, we can just say API like that. Notice I'm doing HTTPS plus HTTP. That says try the secure connection first, and if it doesn't, go ahead and fail over to an insecure connection. But the API name there, it's going to discover exactly where that is and make that connection. I don't have to have a fixed domain name or host name or a port address. It's just going to go find it and connect automatically between the two. Let's start the application, the app host now, and see how the connections are made and how this all works together. So here I am back in the dashboard. Let me try the website. There's the website, and I can click through. And it's clearly loading data for these Alaskan weather sites. Good. But if we go back over to App Host here, we can see in the details of our website that it's making a connection down here. Look at that, Services API. Look at that, way down there. And it has an HTTP connection and an HTTPS connection location. These are variables that are being passed in as environment variables. And if we click into these, we can see it's making an HTTP connection to localhost 5271. That's what we had inside of our app settings JSON. Or it's going to make an HTTPS connection to localhost 7032. So it knows how to find and connect to those automatically. That's really great stuff that helps to make it easier to run our application and discover where these things are scattered throughout our application system. No longer do we have to remember exactly which port is which port. Just reference that friendly name API that we gave inside of our app host. I can just reference that, and it will load up and properly interact with that inside of our .NET Aspire system. That could be any text there. It's up to you what you want to call your components inside of your system. What matters is that you keep that consistent and use that same string everywhere throughout your distributed application. All right, that's all that we have for this episode about service discovery. I've got 2 more episodes for you. The next one, we're going to talk about adding additional components into our application system and how that helps make our distributed application a little bit more interesting. In our final episode, we're going to talk about how we can take what we've built here and turn it into something that we can distribute and run on other production grade systems, whether it's in your own data center or out on the cloud. Hey there, friends. Jeff Fritz here. And in this episode of our Get Started with .NET Aspire series, we're going to talk about .NET Aspire integrations. These are components that you can use to create integrations with other systems that you might want to use inside your application system. Now, that might be a database, that might be an API, that might be a service bus. We're going to take a look at one type of integration and use it inside of our demo that we've been building as part of this video series. Now, if you haven't seen the other videos in this series, I encourage you to check them out because they'll help answer questions like, what is .NET Aspire? How do I install and get started with it on my developer workstation? And how do I get started with the various other parts of the demo project, including service discovery and connecting up some simple defaults that we want to be enabled inside of all of our application system. And as we're building our distributed application, or our application system in this case, we want to enable things like that service discovery and other integrations like we are here. All of the samples, the slides, and even the instructions for this are available in the Let's Learn Aspire repository on GitHub. There's a link for that in the description just below this video that you can check out and follow along. You can take a look at that documentation and find the 5th entry in the workshop about integrations that we're going to work on today. So we've already got a simple application that we've taken from running Blazor inside of one website and a minimal API in another website, and we now have them talking to each other with some resiliency and some logging using OpenTelemetry. But let's start adding some other integrations into other systems. And in this case, we're going to introduce a Redis cache into our API so that it's saving content inside that cache and doesn't have to keep it in memory or anything like that. So we're going to start building and referencing that Redis integration inside of our app host project. Our app host is that central project where we define and orchestrate the entire distributed application or application system, and we're going to have it already have references to the web and API projects. And we're going to introduce a Redis cache resource that it's going to start interacting with. And we'll do that by adding this command, builder.add_redis, right there inside of that program CS. So let's grab that. And inside of app host, I'll just define it right here. All right. Now it doesn't know what Redis is, so we have to install a specially crafted NuGet package. That's a package that's been built in the .NET ecosystem, but in this case, it's been adapted so that it contains information about how to connect to a .NET Aspire integration. So I'm going to grab this NuGet package, Aspire hosting Redis. I'll go over to the command line and we'll add a reference to that package. So we'll execute .NET add package aspire.hosting.redis, and you'll see I'm doing that in the app host project folder so that it knows about that. It's going to go through and tell me it's downloading and checking for vulnerabilities, and over here now it knows how to add a reference to Redis. Now, the name of the service is called cache, and the variable that we're using inside this program CS file is called cache as well. Let's make that a little bit clearer that this is my variable name. I'll call it my cache, just so that you can see the difference in the two places where the variable name is used versus the string name for the service, cache. Now, I want to make sure that that Redis cache is exposed into my website. So under the API definition, where we're going to wire up that Redis output caching, I'm going to pass a with reference method here and tell it you now know how to connect to the Redis cache. So let's do that. Right here, I can say with reference, and it now has a reference to my cache. So just like we saw before when we connected my API to the Weather Hub project, so that the weather website knew how to connect to the API that was defined here. Now we're telling the API how to connect to the Redis cache that's going to be created here. And this Redis cache is going to be created with a container. And on my system, I have Docker Desktop installed. So it's going to start up a Docker container and have that running for me in the background. Additionally, I can also tell Redis, hey, it'd be really great if we had the Redis Commander package running as well, so that I can inspect and peek into that Redis database and take a look around a little bit. And I can do that with a command here with Redis Commander. I don't have to go and identify the package that I need and install it and get it all wired up so that they can find each other. By just adding the with Redis Commander method name there, it will discover, find, load, and connect those two integrations inside of my distributed application here. Let's run the application system and see what happens over there on our dashboard. So here's my dashboard, and you can see it's starting the Redis Commander package there. Now it's done and it's running. You see that state reported over there. But there's my cache service, and you see it came from Docker.io, and it's Redis 7.4, and here's the address that it's running at. And I wouldn't be able to guess that it was running on 62.566 if I wanted to. But my Redis Commander is able to find it and connect to it right away and show you here it is running inside of the Aspire system. And we can take a look at everything that's going on inside that Redis cache if we wanted to. Well, okay, so our Redis is running out there, and we can look at the logs, and we can see all of the logs from the container being reported here. But let's actually now set up our API project so that it uses this Redis cache as its output cache for the API when folks make requests to it. The next step for me to do that is going to be to introduce a NuGet package that has information about the Aspire integration for Redis and knows how to set up the output caching capabilities. And it's this package right here, Aspire Stack Exchange Redis Output Caching. So I will copy the name of that, and we'll include this NuGet package in the API project. So I'll do that at the command line because I think it's a little bit easier for everybody to see how to do that interaction. So in the API project, I'll execute .NET add package Aspire Stack Exchange Redis Output Caching. It'll go through, do some investigation, and after it finishes grabbing it, it makes that reference available inside my API project. I'll go back to the app host project here, so I'm ready to run it in just a second. Next, we're going to instruct our API project so that it knows how to connect to the Redis output cache with this command, builder add Redis output cache. And inside of my API's program CS, I'll just add an entry here. I'll put it right before service defaults. Add Redis output cache, and notice it takes in that string cache, right? That is the name of the cache service that's running inside of our .NET Aspire managed distributed application. So if I go back over to the dashboard, I reran the dashboard at the command line so that we can see what this looks like. That cache string is the name of the cache service right here. It's not the my cache variable that was in AppHost, but it's the name of the service that's declared right here. So it's going to add a reference to the cache Redis service and use that for an output cache. Now we're going to go over to the add NWS manager method, and we're going to remove the output cache declaration that's over there. And there it is right here on lines 85 through 88. I'm in NWS Manager CS inside the API project. You can see exactly where it lives using the breadcrumbs right here. And I can remove this default output caching. And I don't need that anymore because it's been declared over inside of my program CS file. Let's go back and restart our application system and see how things behave now. All right, so there's my dashboard. Nothing new to see here. We can click into the API's details. And if we scroll down inside of there, you'll see there's a connection strings underscore cache entry. And this is the configuration variable that's going to specify where the Redis cache is running. And in this case, it's running at localhost 62.704. And there it is at the top in the dashboard. It's running at localhost 62.704. Okay. Now my API is going to be cached out to Redis. So when I look at the application and I click through some of these entries, right, the values are going to be output cached to Redis. So when I click back through them, they come back immediately. It doesn't need to go and fetch it again because it already has that value sitting in my Redis cache. And we can see that in our distributed trace over here. If we click into the traces and we scroll down a little bit, we can see where it went to get data from the API. And now it gets even more interesting when we look at the trace, because we can see where it was getting a forecast for a specific zone and how long that entire request took. But the first thing it did was it checked to see if it was in the Redis cache. And it didn't have it, so it went out to API Weather Gov to go get that data and came back after it got the data and set the value inside the Redis cache. If I go back, we can take a look just a little bit further down, and we can see here it went to go get for a specific zone, right? We can see exactly what that zone was that it requested, right? AKZ 325 right there. We could see it didn't actually go out to the National Weather Service. It just got the data from our Redis cache. It was cached locally, and it was able to return that without that expensive request to go out to the National Weather Service and get the same data that hasn't been updated since the last time it was cached. Really great stuff that we're able to do and enable with very little work inside of our application. Maybe you want to use a custom Redis container. Maybe you don't want to use the specific Redis container. Maybe you want to use Garnet from Microsoft, or you want to use Valkey. You can swap out and specify a different image name and specify a different image tag by using the withImage and withImageTag methods as part of your API. So if I grab those statements, I can go back to my app host. So here I am, Program CS app host, and I'll just drop in here those statements so that it gets the latest Garnet Redis image, and it'll get the latest version of that as well to use. Now, this is the syntax that we previously used. Because we're fetching this container from an alternate registry besides the hub.docker.com registry, we actually need to change up this syntax just slightly. We're going to specify withImage registry, and we're going to specify that it's coming out of the GitHub container registry. And then we can get rid of that part from the front of our withImage description. Let's go restart our application and see how the dashboard looks. Now, I removed the Redis commander so that we could get Garnet to load here. And there it is. If we take a look at the logs, we can see it's Garnet that's running and it's ready to accept connections. So if I go back over to my Weather Hub application, restart it and start clicking through some of these requests, I can see that it's starting to cache and it's using Garnet now to persist that information. I'll go back over to traces, and we can see where it's using that Redis get and Redis set to interact with the Garnet container now inside of my distributed application. There are so many more integrations that are available for you to use, and you can even make your own custom integrations, but that's a little bit further beyond the scope of this video. Check out the documentation online for a full list of the available integrations that have been signed off by the .NET Aspire team that are available publicly, and you can also find some that might be built and organized and shared locally within your organization, within your enterprise. Hey there, friends. Jeff Fritz here, and I'm going to be talking to you in this last episode of the Getting Started with .NET Aspire series about deploying an application that you've configured with .NET Aspire. Now, there's a handful of other videos in this series that I encourage you to check out that are going to answer all your questions for anywhere from what is .NET Aspire, how do I install it to work with my application on my local developer workstation, how do I configure it, how do I use the dashboard, and finally ending at this episode talking about how to take that application system, that distributed application, and deploy it to maybe a cloud service like Azure. There's all kinds of content around this, including slides, documentation, and sample code that you can get from our GitHub repository. Check out the link in the description just below that'll get you started, and you can follow along with the sample code that's available in the repository. Now, where we left off at our last episode, we talked about configuring additional .NET Aspire integrations like a Redis cache, and even reconfiguring that Redis cache to use a customized container like the Garnet flavor of Redis that's been built by Microsoft. Today, though, we're going to set up and we're going to deploy all of that distributed application to Microsoft Azure, and specifically Azure Container Apps, so that those applications, our API and our website, can discover each other and run together. So when we build an application with .NET Aspire, there is nothing in the application that is tied to Azure or to Azure Container Apps. That's something that's picked up by a secondary tool that inspects the .NET Aspire configuration and decides how to deploy, in this case, to Microsoft Azure. There are other tools that are available that you can use to deploy to AWS or even to Google's cloud or to Kubernetes if you want to use those tools. They're available out there. You can check them out in the .NET Aspire documentation. We have links to that documentation and to those sections in the description just below. But here we want to show you how to use this with Microsoft Azure. Now, of course, we've made the easiest tools to use with the nice click-through wizard. They're all available inside of Visual Studio. So if you're running the latest version of Visual Studio 2022, you're going to see the ability to right-click on a project and choose to publish. So right-click on that app host project, and you can choose to publish, and it'll give you the option to publish your Azure Container App with .NET Aspire. All right? And it'll walk you through a series of questions to help you configure Microsoft Azure for your application system appropriately. But we're not going to do that here. Instead, we're going to use the Azure Developer CLI, or AZD. Now, I have a copy of this already installed and available on this workstation that I installed with Winget. Now, AZD is also available on Mac and Linux systems. You can install it with Brew or APT on those systems. There's other ways to install it as well, but those are two of the easier ways that you can get it installed. Now, over here, I can start configuring my project to be deployed to Azure by using the AZD init command. Let me do that now over in my terminal. So I'm here at the root of my project, and you can see all of the project folders out there, my API, app host, my weather hub, that's the web application, and the service defaults project. All right, here we go. I ran azd init, and it's going to start asking me some questions to set up my configuration to deploy this application to Azure. So how do we want to initialize our app? We have code in the current directory I want you to take a look at. So you'll see here it's scanning the current directory, and it found a .NET Aspire application, and there's where app host is that it can use to configure the application. I'm going to confirm and continue initializing, and I can specify the name for my environment. So I'll call this environment that I'm going to set up out on Microsoft Azure, I'll call this my weather hub. So there's my environment name. It generated some configuration files for me, and it even put some next steps for me in this next steps MD file that I can go through and learn how to do things like configure as part of my continuous integration process. So now that these are generated, I can actually deploy by just executing azd up. So I'll execute that. Oh, I'm not logged in. I need to log into Azure. Okay, so we'll do azd auth login, just as it's suggesting there to do. It takes me out here to my Azure login. I'll click through. Authentication complete. I'm now logged into Azure. Great. So now let's try azd up again. You see here it's going through steps. Downloading Bicep. That's the configuration template, the scripting language that we use to define Azure resources and how they communicate with each other. Now it's allowing me to choose a subscription that I want to use. Let me put that on my Microsoft Employee subscription. I'll put it in East US 2. That's my favorite data center to use. There it is, my subscription, the location it's going to put it into, and it's already started setting up some progress on the Azure portal. And I can click that link, and it'll open up the Azure portal and show me that it's building and deploying, and I can see it's setting up some resources for me, including a resource group called RG-Weather Hub. Okay, that's pretty cool. And back here in the terminal, I can see that it's creating a container registry so that it'll have an instance and snapshots of the container images that it's going to generate for both my API project and my weather project. So each time I deploy, it'll create a new version of that container and deploy it to my own private container registry that's called here Alpha Charlie, so forth. Oh, dear Lord. I don't need to know that because azd and the Bicep configuration that I have will know how to communicate and deploy those appropriately. It's also created a log analytics workspace so that all that telemetry that we had being collected with our service defaults and showing up inside of our trace panel is going to be logged over there so that when our application is running in this production space, we'll be able to navigate over there and take a look at what's going on underneath the covers. All right, now it's moved along a little bit. Hopefully we've edited out a little bit of that content in the middle, and you can see it's deploying services. It's actually deploying the API service now and pushing a container image into that container registry right here. That'll get picked up and automatically deployed out to our Azure Container Apps so that it knows how to run that instance of source code that we've built and is running right now on our local system. And there it just completed, and it's showing me the endpoint right there. Now it's going to deploy that cache service. Now, you might not want to deploy and run Redis out of a container out on Azure. There are libraries, there are integrations that you can set up that will automatically hook up to hosted Azure services, including the Azure service for Redis cache, so that you can use that service that's available for you. It'll provision it and use that standalone service instead of you having to manage a container for this. We're showing this just so you can see how the whole thing runs if you want to deploy and manage containers that have other features brought in from other deployed services out there. And finally, here it's going to build the service Weather Hub and deploy that container image. Notice with both of these, they have an internal domain name. You can't actually access that from outside of the little network that is being built inside my resource group for my Weather Hub. And finally, there's the endpoint for my Weather Hub. It's myweatherhub.bravemushroom-10 whatever. Let's try navigating to that website and see what happens. And there it is. It's running on Azure. It queried and got the data from the API on Azure, and it's displaying my list of various weather stations. So let's go search for something else. Let's search for New York. And there's New York, Manhattan. I'll click into that, and now I get the content for the New York forecast. All right. If I search for just York, and we go click into some of these other ones, and back into New York, it loads immediately because it's pulling it from the Redis cache that's now deployed and running out on Azure. Let's go over and take a look at that Azure resource group so we can see everything that was deployed. So here's the resource group, and take a look at the various resources that were deployed, right? Container registry, 2 container apps, one for the API, one for the cache. I have my container apps environment, some log analytics workspace, a managed identity so that things are secured in how it communicates between those different services, and finally the container app for my Weather Hub. Really great stuff that's all deployed and made available for you out on Azure with just a couple of commands at the command line. And now that I'm done, I can knock it down. I can delete that resource and so that nobody else can get to it, and I can save a little money on my Azure resources. I'm going to go out there and I'm going to delete the resource with this command, azgroup delete, and I'll pass in the name of that resource, RG My Weather Hub. All right, I've deleted that Azure resource group off camera here. Thank you so much for watching. That's how easy it is to get started with .NET Aspire. Use it inside of your application, configure it with some service defaults, some service discovery, get some logging capabilities happening in there, and set up your application so that you can deploy it to either a cloud service or some sort of hosting provider, or even to your internal, your own servers. You can deploy using the exact same commands that you have available, or there's tools like AZD that are available to help you deploy to Azure. Thanks so much for watching.